Greetings. What we've got here, which has been gathering dust for quite a while in my garage now, is a Revelations quiz machine, which actually runs on a LaserDisc. Well, it's supposed to run on a LaserDisc. As you can see, it's not doing very much. This is made by Nova Productions, who accept no responsibility for any program errors, or spelling errors presumably. There's a monitor, there's a computer board in the back, and this Sony Lasermax video disc player, which is an LDP-1450, and this is the this contains the LaserDisc, which it is struggling to put out. It's a bit worn at the moment, but there we go. One big LaserDisc. You can see we've got the, where have they gone? There's the field lines there. I don't know if it's showing up properly on the camera. Anyway, let's have a look inside. Here's inside the back. We've got some lights across the top. There's some lights and buttons here, illuminated buttons. There's the control for the monitor and the VFD there. To the side we've got the Mars ME126 mechanism and hopper controller. This will allow it to redirect the coins down the various chutes, either the two main chutes, or down into the coin box, which is right down the bottom for any leftover money. As I said, this is an ME126 with a validator ME115, and you'll find the instructions for these on the internet. You can download them. There are instructions for programming the validator for the various coins and tokens and things. There's a mystery key switch on the side. Because we don't actually have the keys, it's been disconnected. I can't remember what that does. There's the monitor power supply, so the monitor driver board there as well. Way down the bottom we have the power board, and this also has the cash counters as well. These count the coins coming in and the coins going out. And what looks at first glance to be a switch mode power supply is in fact a normal power supply. It's a linear power supply. It's got these regulators on it and smoothing gaps. This is all low voltage stuff. This is taking some of the various taps off this. And you can see we've got 13, 10, 50 volts. There's all sorts of taps on this transformer. We've got the supply coming in, and then we've got all these extra 87 volt taps, 120, there's 8 volts, there's all sorts of stuff on that transformer. It's a plethora of windings on that thing. And some moss chestnut leaves. Oh, and I found 20p. Excellent. And another 20p. God, it's turned into quite a profitable video with this. Right, let's slide that back home and take a look around the back. Here you can see the back of the monitor, which is in fact a Polo 14 14-inch monitor, and in fact it's an RGB monitor, so I think the RGB encoding is done either by this board here or by something on the main controller board. You can see they've got this harness which disappears off that way, but it could well loop straight back again. I'm not sure. We can see further down we've got this is the rear of the hoppers for coins, and we've got, you can see any 20p pieces will go into here. £1 coins will go in there, 50s and 10s will go down here. Also, if this actually gets full to the brim, you can see there are openings in the pipes there, and any coins, once it gets above this height, they'll fall down this back chute as well, and all these pipes all go together down into there and down into the coin box. Down below then we have, we've got the user manual for the actual the whole machine itself, and also the operating manual for the LaserDisc player, which I think I may have printed this out a long time ago, because when this came to me this didn't work. It was quite a quick fix actually, just it needed a little bit of alignment. On the back of this we have audio and video outputs. There's an RS-232 connection here, and that allows the controller to actually, the controller can choose, it can pick a frame and pick individual frames or run a set of frames on the LaserDisc, so it can show a still image or a short video clip, as you'll see shortly. In fact, I can play the entire LaserDisc end to end, and there'll be a separate video in the link in the description of this video, which shows you the entire video, which runs for, I think it's about 22 minutes of the everything that's on that disc, and it's all in NTSC format, and I think it's constant angular velocity disc, I think, so it's a single revolution of the disc is a single frame. So that's how this can select individual frames, and it just plays it constantly, like it's a rolling pause, if you like. We've got the baud rate controls for this, and in fact this is actually a 120 volt player, so that's where one of the supplies will come from the front. This will actually needs to run on 120 volts via this, and it's even got its own. It's got a separate output jack, one of these American jacks, and a remote plug, because this isn't obviously designed for this. It is an industrial spec LaserVision player, so you may have it controlled remotely by that, but in this it's all done with this, which comes from, let's go past these interlock switches, and that is the board. We have this Lasermax controller board, and that's the one which I think is misbehaving right now. So let's see what's wrong. Because according to the manual, all the supply voltages are correct. We've got these 4 LEDs which show the various supply outputs. So I reckon there's something not right with that board. Here's the board. There's an assortment of chips here. There's a DC to DC converter. There's various glue logic. This is a dual asynchronous communications interface adapter, presumably for the RS-232. There's a versatile interface adapter there. There's the 65CO2 microprocessor. There's a program ROM there, and there's another PROM there. Those are both 32 kilobytes. There's 8 kilobytes of RAM. There are a pair of digital potentiometers there, non-volatile potentiometers, which remember their volume settings after they're turned off. And as I said, glue logic. There's a real-time clock IC there, and a 2.5 watt amplifier there. I'll put a full list of the chip numbers and what they are in the item description. Not in the item description, it's not eBay. In the in the video description. Now, first thing I notice here when looking at this board is I think the problem lies down here. We've got a battery here which has corroded and rotted some of the tracks, including the tracks which are to do with where you would have a program memory card, but otherwise we have the program EEPROM there. So I'm going to check these tracks and chop this battery out and replace the battery. Now, despite the corrosion on the surface of the circuit board, those tracks are actually completely intact. I've done resistance test between the tracks and ground, and also along the tracks, and they're all quite healthy, which is surprising. So I've replaced the battery with this smaller capacity but actually working UASA, little 3.6 volt UASA. So before we go any further, let's see what happens. Yeah, still not happy, is it? That rhythmic clicking sound, I suspect, is a reset. Because it seems to clicking, it's quite a rhythmic click, and every time it clicks we also get a corresponding click from the LaserDisc player. If I take the LaserDisc serial cable out, obviously that stops, but that's not where the clicking is coming from. So I think there's something not right with it, and the next thing to check really is, I reckon, the supply voltages. And one thing I will say now is the backup battery I put in is from God knows where. I did fully charge it, but it may well be not up to the job. I may have to replace it with something else. Let's go take a look around the back anyway. Now, rather conveniently, there's a header here with various supply voltage connections on it. Which could be useful. Let's see what we've got. We've got ground there. Get 4.8 volts on the 5 volt rail, if this is accurate. According to that, we're getting no 12 volt supply at all. But we do get 12 volts on the input side. But that's because that 12 volt pin doesn't actually go anywhere. As you can see, the reset output from the Max 695 is definitely spiking. So it's not happy. It's either not happy with this old battery, which is actually holding enough charge, or it's not happy about the supply, which is showing, it's showing a little low, but it should be within spec. The reset circuitry on the Max 495, so the Max 695, should reset if it drops below about 4.65 volts. So it shouldn't be that. But the other thing that could be a clue is what you can hear right now. There's a lot of mains hum. If I take the speaker connections off, so maybe there's too much ripple on that supply. You can see there's quite a bit of interference on the 5 volt line. For one thing, it's a little low, but also we're seeing about 150, 160 millivolts of interference on there as well, which is bringing this bottom level down very, very close to where the supervisor IC will probably reset the the microprocessor. And besides that, as I've been testing this now, it's been warming up. It's been saying reset RAM and then saying RAM invalid, and now it's saying nothing again. So it's not a happy bunny. Here's the power supply board outside its usual home, and here's the schematic. As you can see, it's fairly simple. Linear power supplies often are, as from what I've encountered anyway. You can see it takes several separate AC inputs and generates a number of DC outputs. We've got 5, 12, 14, 17 and 18 volt supplies. The 17 volt supply being derived from the feed for the 12 volt supply. I've taken the 5 and 12 volt capacitors off and tested them for ESR, and one was, I think it's 0.01 ohms, I think, and the other one was just off the scale. It was that low. So I don't think there's a problem there. I've got it hooked up here to a 12 volt AC power supply to provide the AC input there. Normally that would run on 8 volts, but it's running on 12, and you can see it's happily delivering 23 milliamps, and the voltage, we've got a bit of a disagreement here. Fluke reckons it's 4.94, the scope reckons it's an average, in fact, of 4.96, so it's not that far off actually. I was looking at the peak. So but I can dial this up. Let's dial it up to an amp, for example, and you can see it's hardly dropped. So it's still keeping up, and I think the voltage regulator on here is designed for an amp anyway, so I can dial it up a bit higher. Well, there we go. Drops off sharply there, but it can certainly deliver an amp. And I thought I'd take a look at the watchdog circuit first of all. So I've sketched out a schematic for it, but then I sort of got carried away. Now, the advantage of having done this is you can see what all the chips do across the whole board. You can see which chips are responsible for audio, where the ROM and RAM ones are, the input chips, the output chips, all the various sections that make up this control board. And it also gives you an idea of what could possibly go wrong. For example, any one of these 74LS244 chips, for example, if the inputs to those manage to jam the data bus, or in fact in some of the cases if the outputs of them jam the data bus, it would fail to be able to read the data from the chips, for example. It's not going to start up properly at all. Likewise, if the address bus gets jammed, it's not going to be able to step properly through the program, and it's just going to fail. You can also see there are some of the smaller chips, like these gates. And if any of those failed, they'd knacker up the addressing. So the processor tries to access ROM, for example, and it's getting RAM, or it's getting the I/O ports instead. All things that could get messed up. And indeed, some of these logic gates, you can see there's U24 and U25, which are here on the board. And you see there is some corrosion, especially on U24. Now that would affect the interrupts on the processor, and also some of the read-write selections, so that failure of a quarter of U24, for example, could make the RAM chip read-only. Or U25, it's in all sorts of places. It's used for addressing the Program ROM. It's used for, again, write protecting or write enabling the RAM chip. It's quite a busy chip, and you can see something as simple as that. If that fails, it'll knacker the whole thing. You can see I've added this header here so I can test. I've got some connections I can make. They're easy for testing purposes when I want to test various voltages on the board. I've got the I've got the sound pin if I want it, but there's ground and 5 volt connections here as well. What I also noticed when tracing out the schematic is that a couple of the chips actually get this battery backed supply, including in fact the RAM chip. So even when the power is off, this still actually got power, which surprised me because it's only a 6264. It doesn't appear to be a CMOS part, but it seems to draw that little power when it's not being used, that this is happy to support it. So that, and obviously the real-time clock, which you'd expect to have power afterwards, plus U29, which does the chip selection. So if the watchdog chip detects that the supplier's gone, it can quickly lock the chips so they're not getting spuriously written to. What's also interesting when you look through the schematic is you can work out the address space by determining where the upper address lines go on the 6502, which are into this 74HCT154, which in turn feeds, amongst other things, another 74HCT154 for some of the smaller addressing stuff. The main one, U20, is used for addressing the ROMs, the RAM, the real-time clock, the VIA and Dacia chips, and also then it feeds on to the other 74HCT154, which is U6, and that then is used for smaller addressing of things which need less address lines, such as the VFD, the outputs for the lamps, the watchdog, which comes back to the the Max 695 again, which I think it expects regular watchdog pulses. If it doesn't get regular pulses, it'll assume the system's crashed and will spike the reset to get it all going again. And also it's used for addressing the reading the status of the buttons, reading the status of the coin inputs. If you follow all these address lines to their final resting places, if you like, you get an address list like this. So you can see where everything sits in the 64K of address space that the 65C02 has to play with. Now what's interesting as well, or boring, depends. It depends. If it's boring, then look away now. Is that the system ROM, as opposed to the program ROM, the system ROM, which is a 27256, which is a 32 kilobyte ROM, only 8 kilobytes of that is actually addressed. And in fact, it's the third section of 8 kilobytes. The other 3 8K banks don't get used. I was hoping that there'd be a lot of extra goodies in that chip, and so the chip might come from another system for us to use the same chip in several systems, and depending on which system it goes into, you'd have different programs running. But it turns out that 2 of the banks are completely empty, and the first bank is almost identical to the third bank, except that the interrupt vectors right at the very end of the bank are slightly different. In the bank that we use, it redirects straight into the program ROM. In the bank we don't use, it would address a different section altogether. So presumably running the same stuff but on different hardware, with the ROMs and the RAMs and everything all in different locations in the memory space. Now, first thing I want to do now actually is I'm going to disconnect one of the wires for this battery here and fit a switch. Either that, or I'll remove the battery altogether and run some flying leads off to an external battery pack, because there's plenty of room to take one down here, for example. But it would mean that by disconnecting that, you completely shut the board down. Now then, I've changed the battery. As you can see, the old one I've taken off, and I've fitted one of these little 3.6 volt battery packs. And I've fitted, this one didn't have a cable on it, so I fitted this cable, and I happen to have a connector for it as well, which is suitable. So I've replaced that. That's come off, that's gone on, and you can see now I actually removed these capacitors for testing. They're fine, ESR is fine, capacitance is fine. I removed that 74HCT04 and tested it, it's fine. So I've put a socket there and put it back. The 74HCT08 I broke trying to get it off, so I have no idea whether the original was working or not. It got smashed to bits, and I had no other 74HCT08s in the house. The closest I had is this one chip I've got, which is a 74S08, which is higher power consumption, but I'm only changing the one. The logic levels are pretty much compatible with the HCT that's come off anyway, so we'll see how we get on with there. Oh, sorry, hit the camera. The 74HCT154 I've taken off, tested that again, that works perfectly, and I've put the, again I've socketed that and put the and plugged it back in. So the only component replaced so far, actually replaced, is this 74HCT08, and I know that when I fitted the battery and removed and replaced that, it still wasn't a happy bunny even after I tested these and whatnot. So the latest test now, actually the only thing I'm testing now is having replaced that and removed and resocketed that, and also I've gone through all the chips making sure they're all snug in the sockets, but I'd done that before anyway. So anyway, let's go take a look. The board is now in, I've got the battery connected, all the leads are in. Let's see what happens. Oh, hang on. It stopped making a noise. Okay, we got reset RAM again. Now, just put that back up there. The display doesn't seem too happy with the blue at the moment, but I think it was a bit iffy anyway. Sometimes it displays it, sometimes it doesn't. Right, it's not reacting to those, but looking in the manual, that switch at the side that I wasn't sure of is actually for refilling, so I wonder what happens if I push that in. So I've now got that button pressed now, which would be the key switch over on the right hand side. That's more promising, that's much more promising. Now what this means, having looked at the circuit diagram, obviously there's nothing jamming the address and data bus, otherwise it wouldn't be able to flash the lights, for example. It wouldn't be able to write to the display. That would still display because that's written straight from the LaserDisc, but it wouldn't be able to do that. It wouldn't have been able to recognize this button. It would have just crashed out again like it has been doing. It'd be nice if it would do something else. Well, the LaserDisc is definitely working. Actually, what time it was now? It's the 11th. How does this work? Let's try. Sound works. Now then, let's see. The old year 2000 bug is alive and well. Okay. We'll have to have 1914 then, I think. What's the time? Which I think is... Right, now it's grumbling because the I think because that refill switch is still in. So what this means is that what you do is you shovel coins in, just to fill up those tubes. So you know, so it's at least if someone wins something, it's actually got something to pay out. rather than you putting in a completely empty machine and hoping that enough people stock it up before it actually has to pay out. So let's go and take the reset that refill switch back off. Hey! She runs again. You see, this is the way the LaserDisc works, where it'll actually choose individual frames or whatever from the game. Let's check some money in. Oh, that's Enterprise. So I win something out of this now. Oh, Manchester. There we go. Was that Simply Red? Was it? I don't know. Okay, no entry, no right turn, no left, no overtaking, priority, waiting. Oh, there we go. I'm getting no money out of this thing. Not today anyway. But that's working. Obviously there's an issue with the RGB signal, which is coming off from the from that sideboard, which I think is worth taking a look at now. But as I said, sometimes it seems to start up okay, sometimes it doesn't, so maybe it's a bit temperamental in that regard. Well, the next thing I want to take a look at while I've got it here is see what we get out of that serial interface, because it's got that extra socket on the back. I want to know what goes on with that. But now I've got the time set and the battery is set as well, I should be able to turn it off. And yep, it boots straight up properly now. But before I do anything with the serial port, let's take a look at what we can do with these switches, because there are various switches on here besides the refill switch on the back, because we've got these ones here which normally the front door would hold in, and when you take the door off they pop out so it knows that the door is open. But you can also pull them into test mode. Now the one on the back, for example, is in test mode right now, so that it can actually run with the back door off. There are two on the back. One will shut the power off, and the other it puts it into, well, we'll see for yourself now. Let's pop this top one. But now it thinks the door is off. So let's see what we got. We've got test options here. Button A and B to select the test. Button C to initiate the test. So we've got lamp test. Now quite a few out. Coin out meter test, which should, let's take a look. Should clock, and it's not clocking, so we've got a fault with the coin meter. We test the display. logic sound. So that's the stereo audio from the LaserDisc player. This will test the onboard audio. Payout solenoids. I'm going to turn the refill key for this one, so let's make it think it's in refill mode. And that's interesting because it does have money in it. I've just fixed the coin mech, and that was a little bit of a fiddle. We might as well take a look at it while we're here. You can see on the right hand side we've got the £1 coin mech, and this chute here normally sits over this slot. So if the thing is too full of coins, they start to fall down this, which has a chute which goes down here, and the chute is somewhere else at the moment. We put it out of the way. Oh, here we go. It's just one of these pipes. On the right, sorry, that's on the right. On the left, we've got the 20p one, and I've taken the chute out because it was actually jammed up with the pound coin. You can see these are different mechanisms for different coins because of the different coin thickness. If you take a look down there, you can see the way it works is that the solenoid will pull back like that and let go, and that means that if you've got a pound coin, if you've got a 20p piece in the hatch there, pulls back, catches the coin, goes forward, shoves it out. If, as it was, it's got a pound coin in it, it'll pull back, catch the coin, and it's stuck. And that's what had happened. It had a couple of quids worth of coins. In fact, I got £5.20 including this pound coin now out of the machine, but it's probably all my money anyway. But you can see that was stuck. So basically, I had to take the tube out, fish all the coins out, and try and get that one out as well. Then, which is basically a screwdriver job with the solenoid out of the way. Obviously a lot easier with the camera in the way, but there we go. That's now that working again, and of course these are what's fed by the triax rather than the coin mech. So not the coin mech, the coin counter. So these 50-volt solenoids are now fixed. So I shall put the back on there. Is there anything else to look at while we're in here? We can have a closer up look now, a well lit look. You can see the 20s will go down here, 50s, pounds will go down there, so it would store 20s and pounds ready for paying back out. Any 50s and any 10p pieces would never be paid out in money. It would all go straight down this other pipe, and of course they all go together down there, down into the box. The coins are now in the correct tubes, so let's see what we've got. Test options we're still going through. Lamp test already done. Switch test. Monitor setup size. That's an interesting one. What's that? Oh, there we go. You can actually adjust the position of the width and everything of the monitor, which isn't really necessary because on here we've already got the options on the front panel. What else we got? Color bars. You see there's a little bit of white. There's not much blue. There is some blue there, but not a lot. I don't know whether that's the monitor or whether it's the RGB converter. It does seem to come and go. payout solenoid. So here we go, let's try those again. Turn the refill key. This time I should be able to get a pound and a couple of 20s. Let's find out. Here we go, I've won. That's the last of the coins. Does seem to go rolling through its own self-test once you... There we go. Now if I there's no way of exiting out from there, so what I've got to do is effectively close the back door. Open it again. So A, game options. Price of play, we can choose between, oops, didn't want to do that. Game options. A to select option, B to change, C to execute. Price of play. Don't know what that's done. Okay, let's try that. This has been an odd. I'm still recording. Yeah, it's a bit of an odd setup, this one, because I can't select any options. All I can do is press that. See what happens if I exit out. Even if you exit, it'll try and reboot anyway, so it'll be close the back door. Still 20p to play. That will make a difference if I turn the refill key. It doesn't seem to want to let me change the gameplay price. But it has now forgotten the date and time. Now the reason I think that it can also do 30 pence to play is because this is the list of all the text I've found in the Program ROM. There's no text at all in the system ROM, but these are all the messages I've found, and you can see there's 20 or 30p to play, and there's also insert 50p more if you want to play the card game. So I don't know what triggers that card game option. Monitor setup size, of course it's not adjustments from here, it's actually a test card basically, so you can adjust the video output using the controls down below. That's what that one is for. Same again with the color bars there for use with those settings. P-out solenoids now work. just so I chuck a pound coin in, and of course I've got to turn the refill key for this. Always forget. You see those are working. And while it's in refill mode, it does seem to cycle through a lot of these options. You've got to take it back out if you want to manually select them. Of course, we know the audio is working. Alphanumeric display. The coin in and coin out meters are now working. And that's the lot as far as the tests go. What I still haven't managed to do is change any of these game options. You can see I should be able to select an option with that. We know the button works, and I should be able to change the option and press C to execute it, but all it wants to do is take B and restart. Of course, this now, because the coin door is open, it gives you the option now to show on the display how many coins it's had in, how many coins it's paid out, and how much has gone in on the refill. Obviously, that's since I reset it earlier on, and that's with the button down the front. Now, looking at this list of all the text that's hidden away in the Program ROM, I don't see an awful lot extra. It may be that some of these loss and win ones will turn up on the serial interface, and hopefully it'd be nice if there's an option for meddling around with those settings, the 20-30 pence settings, or enabling the card game. Let's find out. This obviously is the monitor outside the chassis. You can see it just mounts with a couple of mounting bolts on the front, and it's designed as a complete, basically open frame monitor. This was made in May 1993, so it's just over 21 years old. And you can see it's a Hantarex Polo 14-inch. We've got a connection here which goes to the front panel board you saw earlier on, where all the width and height controls, instead of being on the back panel, they're actually on an extension lead, so you've got them on the front of the machine. And we've got the mains, and we've got the sync, ground, and blue, green and red there. So you'll find schematics for these are quite easy to come across. There's not so much information on the decoder board though. Now this is apparently made by Hantarex as well, even though there's no markings on it to say as such. I found one photo of the PAL version of this, and obviously this is the NTSC version, so it's got there are a few component differences. There's an extra control here. This is the hue control. I haven't found any schematics on the net for this, or any user manuals, so I've made one. And this sits on this metal frame, which is designed to screw straight onto the side of the monitor chassis there, using the 3 screw holes. So you've got your NTSC coming in and some power, and then you've got your RGB and sync coming off the other end and going straight into the monitor itself then. Although the harness for wiring that is actually part of the harness in the game machine itself. There's no short cable on this. You can see we've still got this fault on the blue where there's no blue. There's very little blue. You can see there's a slight difference between the yellow and what's supposed to be the white, but by and large there's no blue on that display. And I don't know whether that's a fault with the monitor or with the RGB encoder. The easiest way to find out whether it's one or the other is to swap 2 of the outputs from the RGB encoder. I can swap the blue with the red or a green and see if this pattern changes. Let's find out. Red and blue swapped over, and it looks like it's the monitor because there's plenty of red still showing up where the blue would have been, and there's still no blue on the screen. So we need to try and troubleshoot a bit further in. Fortunately, there are schematics for these monitors easily available on the internet. That's more like it. Now, all I've done is swapped 2 transistors and 1 capacitor between the green and the blue output stages on the neck board of the monitor, and it seems to have fixed it, which is not really a satisfying repair, if you like, because I don't really know what the fault was. You know, it may have been just a dodgy solder joint. It could have just been me unplugging from the tube neck and plugging back in. I don't know, but it's working again. We've got white. We've obviously got the red, the green, and the blue, all working. Well, that's all fixed now. It just needs a new front door, really, down the bottom, because cleaning all the all the edge connector contacts has brought all the rest of the lights working. So the pound one is working as well. This stopped working, then it came back. The coin meters are now working properly rather than intermittently. But I think I've covered everything on this thing now, really. We've gone through fixing it, well, sort of fixing it. You know, it's working now. It wasn't working before. Fixing the monitor and looking at the monitor, looking at a quick look at the coin mech, looking at the slot things around the back. Obviously a damn good look at the boards. I think there's not a lot else to look at really on this. I mean, I could pop the LaserDisc player open, but maybe I'll leave that for another video. Hope you like it. Thanks for watching.